All right, this is the Honors Math 2 Unit 5 review. I'm going to try to live stream it. Could be successful or it could be a terrible mess. Let's see how it goes. So, number one, we need to find the value of j in our parallelogram. This one's using the properties that diagonals bisect each other. So we're not so much going to use these values here because you don't know the two values of the diagonals in this direction. But we do know 4j minus 19 and 2j plus 3 are corresponding. Not corresponding, but part of the same diagonal. So we'll go 4j minus 19 equals 2j plus 3. We then subtract over 2j from both sides. We're left with 2j on the left. Add over 19, we get 22, and j comes out to be 11. For number 2, we need to find the value of b. This one's going to use the property that opposite sides are congruent. So from here, we're going to go that b plus 14.5 equals 20.5. We then can subtract the 14.5 from both sides, and we get that b is 6. For number 3, we need to find the value of s in our parallelogram. The rules we have for a parallelogram are opposite angles are congruent, and then that consecutive angles are supplementary. These angles are consecutive, so we're going to set them up as supplementary. We'll go 8s plus 5 plus 3s plus 10 equals 180. We then combine them to get 11s plus 15 equals 180. Subtract the 15 over, we get 165. And this is why we should not have s as a variable because it looks like a 5. But then divide by 11 and s comes out to be 15. For number 4, we need to find the measures of our numbered angles in a rhombus. Things we should know about a rhombus is the diagonals are perpendicular. So that first tells us that the measure of angle 1 equals 90 degrees. Then we can go and look at angle 4. So I know opposite angles are congruent in a parallelogram. I also know that the diagonals bisect the angles in a rhombus. So in that case, the measure of angle 4 is also going to be 25. Now, if I needed the total of these two angles, it would be 50. I could then split it again on this side, and I get the 50 divided by 2 is 25. But what we're also going to do now to find over here, I know 2 and 3 should be the same, and I know the angles next to them should also be the same. So I'm going to think of this right here as a right triangle, where I know I have a 25, I have a 90, and I need to find the other angle. So 90 minus 25 leaves us with 65 degrees here. So the measure of angle 2 is 65 degrees. And the measure of angle 3 is also 65 degrees. We go to number 5. We're having a rectangle. I know the angles are 90 degrees in a rectangle. That doesn't so much help me for this problem. I also know, though, the diagonals are congruent. Since they also bisect each other, what I really get here are little isosceles triangles. So this problem isn't so much of finding angles in a rectangle, it's understanding we get an isosceles triangle, and that in an isosceles triangle that these two angles are going to be equal to each other. So 5x plus 10 equals 6x plus 3. We subtract the x over, or 5x over, we have x. Subtract the 3, we get 7, and x equals 7. Number 6, we're going to classify each quadrilateral by the most specific name. So we could call a lot of these parallelograms, but we have to look at the information we have to go a little bit further. In the first one here, I do have the parallelogram. Opposite sides are parallel. But what also happens here is right here, the diagonals bisect the angles. What happens there, and we could kind of use the property that comes with the rhombus, but again, we have little isosceles triangles with CDE and EFC. So these now are the same side, and then FE and CF are the same side. And in fact, they're congruent triangles, so we get that all 4 sides are the same. So our best name for that is a rhombus. In number 2, for some reason, we're missing part of that box, so we're just going to imagine that it would fill in this way. We don't have diagonals labeled. Even though it looks like a rectangle, I have no right angles there. So our best guess for this one is just going to be a parallelogram, and that's because opposite sides are parallel, both sets of opposite sides. The next one, we have diagonals perpendicular. Whenever diagonals are perpendicular, that qualifies us to have a rhombus. We don't have any diagonals congruent. We don't have any right angles for it to get to a rectangle and maybe eventually get to a square. So we're just kind of leave it as that. Number 4, we have NP and OQ. NP is the full diagonal. OQ is the other diagonal. So that tells us that these two diagonals not only bisect each other because they're a parallelogram, but they're also congruent. And congruent diagonals tells us we have a rectangle. Next, we're going to go up here. We have right angles and opposite sides congruent. Now, if these were marked as the same, we could maybe go rhombus and probably square, but nope, it's not. So we're just going to stop with rectangle. My handwriting is really bad on here. All right. Next, we have 4 congruent sides. We have 4 right angles. Sides give us rhombus. Angles give us rectangle. When we have both of them, we have a square. To the right there, we have 4 congruent sides. That's all we have. So 4 congruent sides guarantees that we do have a rhombus. The next row down, we have one set of opposite sides that are congruent and parallel. This is a not very often used rule, but this is also how we get a parallelogram. So we know we at least have the parallelogram. Now, because that happens, we also have here that this is a right angle. In a parallelogram, opposite angles are congruent, so that's a right angle. I also have consecutive angles or supplementary, so I know that these two are right angles. So in that case, it becomes a rectangle. Next to that, 4 congruent sides is going to be a rhombus. Moving down, we have opposite sides congruent, so we're going to go parallelogram. Here we have one set of sides parallel, and the non-parallel sides are congruent. So normally, the one set of parallel sides give us a trapezoid. And then when they're congruent non-parallel sides, that's an isosceles trapezoid. But if we look a little bit further, if it's an isosceles trapezoid, we know base angles are congruent, so that would also be 90 degrees. And we also know that these two angles would have to be supplementary, partially because they're same side interior angles, but the other reason is that's the rule that we get for a trapezoid. Now, if one of them is 90, then this one is 90, and this one is 90. So it actually becomes an isosceles trapezoid where you have 4 right angles, which actually breaks the rule for a trapezoid because now we have opposite angle, or both pairs of opposite sides are parallel. So this actually becomes a rectangle even though we started off with it being a trapezoid. That little right angle there eventually led us to get to it. Next one down, we have opposite sides parallel, but also opposite sides, or all 4 sides congruent. So that would be a rhombus. Here we have all 6s, so that guarantees at least a rhombus. But this right angle here, because it's at least a parallelogram, tells us supplementary goes here, opposite angles here, and supplementary here. So this one becomes a square because it's a rhombus due to 4 congruent sides and a rectangle due to the right angles in a parallelogram. Next one down, we have opposite sides congruent, opposite sides parallel, but also the right angle there goes to all of them because it showed up in 1 in our parallelogram. So we're going to go rectangle. Here we have all 4 sides congruent, and it is a parallelogram. So we're going to say rhombus. All right, moving on. A parallelogram has perpendicular diagonals and angle measures that are 45, 135, 45, 135. So let's check out what we got here. We know it's a parallelogram, so we got that much as true. Now, if it's perpendicular diagonals tell us it's a rhombus. Now, if angle measures are 45, 135, 45, 135, it doesn't really help about the fact it's a rhombus. We already know that qualifies. What that tells us, though, is it's not a rectangle, which means it's not a square. So the perpendicular diagonals give us rhombus. The non-90 degree angles tell us it's going to stay a rhombus. A parallelogram with perpendicular and congruent diagonals. So now we have, that was a terrible line. That's not much better. We're just going to scratch that one out. Let's go up here and use this one. And that line's even worse. Okay, up here, if we had congruent or perpendicular diagonals and congruent diagonals, that finally gives us a property from a rectangle, the congruent diagonals, and the perpendicular diagonals from a rhombus. So we're going to go square for that one. A parallelogram with perpendicular diagonals and angle measures that are all 90. That kind of fits to what I set up here with A. This one is going to be a square. Perpendicular diagonals give us rhombus, and 90 degree angles give us a rectangle. Together, that's a square. For D, a parallelogram with congruent diagonals. As with part B, congruent diagonals give us a rectangle, nothing else. We have no property from a rhombus. We're going to stay there. Okay, number 8, true and false. All kites are quadrilaterals. That is true. It's got to have 4 sides to be a kite. A kite is a parallelogram is false. It does not meet any of the conditions for a parallelogram, notably that opposite sides are congruent. Also, one of our definitions in a kite is that the opposite sides are not congruent, but the adjacent sides are. So that's a false. A kite can have congruent diagonals. At first, we say no, but that is possible. It's not in all of them. And it's not that we are bisecting them. It's when we draw our kite, which looks terrible here. It is kind of offset, this horizontal diagonal, but let's say it's 10 units and this one's 10 units. There's nothing saying that the horizontal one can't be 10. I mean, these could both be 5, but maybe this one's 3 and 7. So it is possible. It's not every time, but possible sometimes. Both diagonals of a kite bisect the angles in the vertices. That is false. Only one diagonal will bisect. This diagonal, the horizontal diagonal in my terrible drawing, would bisect those angles. The top and bottom here would not. Rhombuses have 4 congruent sides. That is true. That is the definition. Rectangles have 4 congruent angles. That is true. Diagonals of a rectangle bisect opposite angles is false. That happens in a rhombus. Diagonals of a rhombus are always congruent. That is false. That happens in a rectangle. Number 9, we're solving for our mid-segment, and the rule there is x equals x minus 8 plus 2x minus 12. So we're going to add the two bases, divide by 2. We're finding the average of them. I'm going to multiply over the 2 to the other side. I get 2x equals 3x minus 20. Subtract over the 3x, I get negative x equals negative 20, and x equals 20. For number 10, these are my base angles in an isosceles trapezoid. So we're going to go 117 equals 3n. We divide 117 by 3. We get 39, so n equals 39. Find the measured angles of our rhombus. We saw one similar to this earlier. First, we know that the measure of angle 2 is 90 degrees because diagonals are perpendicular. I know the measure of angle 4 is going to be 52 degrees because in a parallelogram, opposite angles are congruent, and then in a rhombus, they are bisected. And then really it becomes this little right triangle here where I have 52, and I need to find the other angle to complement. So we'll do 90 minus 52 to get the measure of angle 3, which is 38. And then that would also be the same thing as angle 1, which is also 38 degrees. Here we need to find our coordinates. So we have an isosceles trapezoid with a base centered at the origin, bases of 4a and 2b, height of c. So if the height is c here, and our bases are 4a and 2b, I know from O to L it's b. O to M is B. The y-axis to J is 2A, and the y-axis to K is 2A. So when I find these coordinates, I'm just going to follow those directions. Now, they're not values, they're just letters, but I can still do this. So I'm going to go, L goes B units to the right, 0 units up or down. So it's B0. M is going to be negative B units to the left, 0 units up or down. J is going to be negative 2A to the left, C units up. And K is going to be 2A to the right and C units up. Now for 13, we have our parallelogram with height M. So let's label that. Point Z is J away from the origin. So now we're going to find our coordinates here. Now it doesn't look like we have a length here. So we know M and J here. I know Z is at least J0. W is 0M. We could use the distance formula to find the length of this side and then add it on, but that'd be a little more complicated than we need here. Looks like I'm missing a part, so we're just going to stop here. X, we would know, would go over the same amount as ZY, and it would go up M. And then Y would go over that amount ZY, and it'd be up 0. And I'm just going to leave those points there because it looks like we kind of have an incomplete problem from what we had. Okay, number 14. Just going to kind of sketch out what I have, not to scale. That is a terrible line. Let's see about better access. Hey, it's a little better. Okay, so we got 0, 0, over 2, up 5, and over 5, down 2. Okay, I need to find the fourth point. Now, there's actually 3 different options. I'll show you how I get to one of them. So one way I could get to it, if I went from the origin to here, I went over 2, up 5. So that means down at the point 5, negative 2, I'm going to do the same thing. So we went up over 2, up 5. We're going to do the same thing from this point because opposite sides are parallel. So if we go over 2, that takes us to 7 for the x value. Up 5 takes us to 3. So one of our possible points would be 7, 3. Now we could also check if this works because to get from 0, 0 to 5, negative 2, I went 5 right, down 2. Now from 2 to 7, I went 5 to the right. 5 to 3, I went down 2. So 7, 3 is my possible fourth point. Now, we can also go back and we can check, because that's really just to make it a parallelogram. It says we want to make it a square. So from 2 to 5, if we did the distance formula, let's label here. We have A, B, C, D. Now, instead of distance, let's go in and let's do slope. So the slope from A to B, it goes up 5 over 2. We know the slope from D to C goes up 5 over 2. The slope from B to C went down 2, 5 to the right. The slope from A to D went down 2, 5 to the right. So because opposite sides are parallel, because they have the same slope, we know it's a parallelogram. It's a terrible parallelogram. Okay. What we can also do from that is we now know it's a rectangle because the adjacent sides are the opposite reciprocals. So if I look at 5 and 2, 5 over 2 and negative 2 over 5, those are opposite reciprocals, guaranteeing that all of these are right angles. Now the last part is we have to make sure it is a rhombus as well to make it a square. So we could look at the diagonals and their slopes showing they're perpendicular, but I'm just going to go in the distance and find the distance from A to B. The distance formula is the square root of the change in x. So I went over 2 squared, and then change in y squared, 5. So this becomes 4 plus 25, which is the square root of 29. Now, I already know it's a parallelogram, so opposite sides are congruent. What I have to make sure is that all sides are congruent. So if I could show also that AD and AB are the same, that would be enough to guarantee that all sides are the same. So let's check AD. AD, I went 5 to the right, down 2. So I went 5 squared plus 2 squared. I'm not worried so much about negatives because I'm going to square them anyways, and I get 25 plus 4, which is also the square root of 29. So now I can say all 4 sides are the same. So it is also a rhombus. So check parallelogram, opposite sides parallel, check rectangle. Adjacent sides are perpendicular with the slopes, opposite reciprocals, and check being a rhombus, all sides congruent. So we'll say it is a square. All right, in 15, we have to show what we have is a rhombus. We want to show that TYXW is a rhombus. Right now we have TYXW as a parallelogram. So let's label some other parts we have. We have TP and TZ, then WZ perpendicular to TY, and YP perpendicular to TW. So from that, let's look up here. So I need to show it's at least a parallelogram. So I got that. So what I need to go from a parallelogram to a rhombus is show that all 4 sides are the same. So let's say I wrote all the givens here. I'm not, you should though, because, well, my handwriting's terrible on here. But with what I have there, I need to get all 4 sides the same. Now, I already know opposite sides are the same. So I know that YX, not angle, YX is congruent to TW. And I know that TY is congruent to WX. My goal here is to get YX congruent to TW, congruent to TY, congruent to WX, because that's going to lead me to saying that TYXW is a rhombus, since the definition of rhombus says 4 congruent sides in a parallelogram. Okay, when you write this out, you need to write it a little bit cleaner. But off that thought, I have 2 triangles here. I have this intersection, but I kind of want to look at this triangle and this triangle, because if I can get those 2 to work together, I can then say that TY and TW are the same, which would give me the congruence. So off of that, let's see here. We got these from the definition of, not definition, but opposite sides congruent in a parallelogram. I'm going to say that angle T is congruent to itself. So that, in those 2 triangles, gives me that congruence. I also have actually this right angle here. So in TZW, I have an angle, a side, and an angle. In YPT, I have an angle, this angle. YPT, I have angle, side, angle. So I can say those 2 triangles are congruent. So I would then put in triangle TPY is congruent to triangle TZW by angle, side, angle. Because of that, I know that TY is congruent to TW because corresponding parts of congruent triangles are congruent, which then lets me connect the fact that TY and WX are congruent and YZ and TW are congruent, which gets me to this statement, which is what I wanted. And we could say their transitive property which then gets us to say, well, it's a rhombus because the 4 sides, 4 congruent sides in a parallelogram. Now, this was not very clean, but hopefully you at least see the thought process we wanted as we went through it, and you could go through and write that proof through by yourself. Now, 16, we have here that KRPM is a parallelogram. We have JRK and PMO are congruent. So let's kind of talk through a plan here and see where we could go. So I'm going to use opposite sides congruent. Gives me that. I could also go